Hello class. Today we start on the chapter 5, control charts for variables. So in this video, I'm going to talk about the quantitative computations for building up the Xbar chart and R chart. And for all the other information, you need to refer to the slides for a more comprehensive understanding of the control charts for variables. So the control chart method for variables is a means of visualizing the variations that occur in the central tendency and dispersion of a set of observations. So the Xbar, so we have two charts, right? This Xbar for the central tendency and this R for the dispersion, the range. So here's how we build a control chart. You take different inspections at different time periods, right? So for example, for the first subgroup at 8:30 a.m., you go to the production line and then you take 4 samples. And the 4 samples reading are 55, 52, 51, and 53. And then you need to compute the Xbar value, the average in this subgroup, which is 52.8, and the range of this subgroup, which is the largest value in this subgroup minus the smallest value in this subgroup, 55 minus 51 equals to 4. So in the Xbar chart, you need to place this point is 52.8 associated with the first subgroup. So the horizontal axis in the Xbar chart and R chart stands for the index of subgroup. Okay. And for the second time, after an hour, you go back to the production line and then take another 4 samples for inspection. And then you have these 4 readings. Again, you need to compute the Xbar value and the R value for this subgroup. And then you record these 2 points for the Xbar and then for the R respectively. So what we have, the solid bar in the middle, is called the central line. So this is the central line for the Xbar. This is the central line for the range. And usually this will be set as the average of your subgroups. So this will be the average of subgroup averages, and this will be the average of subgroup ranges. And the lower control limit and upper control limit are usually set as plus and minus 3 standard deviation from the central line. So if every subgroup has the mean that is between the upper control limit and the lower control limit, then that means there is only natural variation. So we call this chance causes. So there's only chance causes for those expected variations in your samples. If there are some samples that is fall beyond the UCL or LCL, that is below the lower control limit or above the upper control limit, then it may indicate that there is some assignable causes. So assignable causes are very large in magnitude, is readily to be identified. If you know your process is in trouble, if you know something is going wrong for the process, and of course the sample product must be out of the specification, then this is some assignable causes. And of course, sometimes the chance causes can make some points out of the boundaries, out of the limits as well. We have 6 steps to build the control chart for the average and the range for Xbar and R. So the first step is to select the quality characteristic, which measurable variable that you need to define to characterize the quality. And second, you need to choose the rational subgroup. So what is the rational subgroup? What is the rational number of samples in one subgroup, and how many subgroups you need? The third is to collect the data using different techniques. So most of the time we will use the same interval and then to pick the samples at the beginning of each interval. And the fourth step is to determine the trial center line and control limits. The fifth is to establish the revised central lines and control limits. and 6 is to achieve the object to keep improving the qualities. So in these 6 steps, the step 4 and 5 are more quantitative, and I'm going to talk about it in this video. For all the other steps, you need to refer to our slides. Step 4 involves computing the trial central line and control limits. So that G stands for the number of subgroups. So we have a total of G subgroups, and this Xi stands for the average of the S subgroup. So what we need to set for the central lines is the average of subgroup averages. So it's an average of averages. You sum up all the averages from all subgroups and then divide it by the total number of subgroups. And this gives you the X double bar, the average of subgroup averages. And this R bar stands for the average of subgroup ranges. So you sum up all the ranges in different subgroups and then divide it by the total number of subgroups. So we use X double bar to set as the trial central line in the X bar chart, and we use this R bar to set as the central line of the R bar chart. Here is an example to find the central lines. So we have, so for the first column, records the subgroup number. So we have a total of 25 subgroups, and each row stands for one subgroup. So the subgroup 1 is this inspection was taken on December 26th on the 8:50 in this time, and then we take 4 samples, right? This X1, X2, X3, and X4, and then you need to compute the X bar, the average of these 4 samples associated with this subgroup 1, and also the range of subgroup 1. The comments will put some assignable causes. So for example, this 4th subgroup has the production that is produced by new temporary operator, and like this subgroup 18, it has damaged oil line. So these comments will record these assignable causes. And 25 is a minimum number of subgroups that is required to build the control charts. So in this case, we take 5 samples in each day, and therefore we need 5 days of records to build up to 25 subgroups. So now the G equals to 25, a total of 25 subgroups, and then the X double bar is the average of X bars. So now you have computed this X bar for each subgroup, and then you sum up them together and then divide it by the total number of subgroups, and this gives you the X double bar, 6.41 millimeters. And for the R bar, it's also you have this range computed for each subgroup, and then you sum up all this Ri together and then divide it by the total number of subgroups, and this gives you the R bar equals to 0.0876 millimeter. The control limits are established at plus and minus 3 standard deviations from the central value. Okay, so this upper control limits for X bar is the central line, the X double bar, plus 3 times the standard deviation of the X bars. So this sigma X bar stands for the population standard deviation of the subgroup averages, and this sigma R stands for the population standard deviation of the range. So somehow these are difficult to compute, or even you don't know the population standard deviation. Therefore, in reality, we provide some parameters to estimate these standard deviations. So in practice, calculations are simplified by using the following equations, where this A2, D3, and D4 are factors that vary with the subgroup size and are found in Table B of the appendix. So you can see that the upper control limit and lower control limit of X bar is defined as the X double bar plus and minus a multiple of the mean of range, the average of range, sorry. So what this A2 is, you do not need to compute the A2, but you need to look up this A2 value from table B. And this A2 values only depends on the subgroup size, which stands for the number of samples in one subgroup. Okay, and for the control limits for the range, we define that the upper control limit and lower control limit for the range is a multiple of the average of the range. Okay, so this D3 and D4 will also be looked up from the table B. So here is a view of the table B, factors for computing central limits and 3 sigma control limits for Xbar, S, and R charts. So the first column stands for the subgroup size. This means the number of samples in one subgroup. So for our example, we take 4 samples in each subgroup, and therefore we need to look at this row, right? This row associated with 4. And the first 3 columns records the factors for control limit for the Xbar chart for averages. And these 5 columns in the middle are associated with charts for standard deviations, which we're going to talk about in our next lecture. And the last 6 columns are associated with the chart for ranges. So let's go back to have a look at the formula, and then we need to get the values of A2, D4, and D3. So here, associated with subgroup size of 4, the A2 value is 0.729, the D3 value is 0, and the D4 value is 2.282. So the D3, as you can see in this formula, defines the lower control limit for the range. When we have a sample size that is smaller than or equal to 6, this D3 is always 0, so that means our lower control limit for the range is 0. When you have a range equals to 0, that means all of your samples have the identical readings. So you have just the same 4 data points in your subgroup. And that means you have no variation in this subgroup, right? This actually means something good. So normally we just set this LCL for the R to be 0. And if you have a larger number of samples in one subgroup, this LCLR may become a positive number. But if any point fall below the LCLR, that means this subgroup is exceptional, great, or excellent for the performance, because it has a range that is even smaller than the lower control limit, aka your samples in one subgroup are close to each other. So now we continue to work on this example. We have already computed the 12 central lines, right? The X double bar and the R bar. And now from the table B, we got the values of A2, D3, and D4. Therefore, the 12 control limits for the X bar is defined as the X double bar plus A2 times R bar. So the X double bar and R bar are the values that you need to compute, right, in the first step. And then this A2 is looked up from table B. So we just copy this value from table B, and therefore you can find the upper control limits for X bar. And for the lower control limits for X bar, you just use a minus sign instead of the plus sign here, and then plug in these values, and then get this LCL for X bar. The 12 limits for the R chart for the range, so the upper control limits is the D4 times R bar, and R bar is already computed in the first step. So you look up for the D4 value from table B, and then times this R bar value, and then gives you the upper control limits of the range, 0.2 millimeters. And this lower control limit is set to 0 because the D3 is 0. So here are the X bar chart and R chart based on the 12 central lines and the 12 control limits. So you may identify that there are some outliers, right, of the points that is beyond the control limits. So what we need to do next is to revise these specifications, to revise these central lines and the lower and upper control limits for the next round of inspections. So the revised control limits and central lines are designed for the future use. Okay. Now let's first examine this Xbar chart. We have three outliners, right? So the first one is for subgroup 4, and in our example, we can see that there is an assignable cost, the new operator. So the average of this subgroup is higher than the upper control limit because it is produced by some new operator. And therefore, we can discard this point for the future use, because this is not likely to happen repetitively in the future, right? And this one, subgroup 20, is also an outliner. It also associated with an assignable cost, the bad material, right? So we can discard these points for the future use. We do not need this. And this point falls below the lower control limit, but there's no comments for this subgroup 16. So subgroup 16 is expected to be in a natural production variation, so it should have been within the control limits, but however, due to some chance cost, it fall a little bit lower than the lower control limits. Okay, so we still need to keep this point for the future reference. Now for the R-bar value, for the R-bar chart, we can see that we have only one outliner as subgroup 18, and this subgroup is also associated with some assignable costs, the damaged oil line, and therefore we can discard this point in the R chart. So now for your future revised central lines and revised control limits, you need to discard this point for Xbar chart and the R-bar chart respectively. Okay, so you take 2 points. So even though you take subgroup 4 and subgroup 20 out of the Xbar chart for the revision, but you still keep subgroup 4 and subgroup 20 in the R chart. And similarly for the R chart, you discard this one, the subgroup 18, but you still keep this subgroup 18 in your Xbar chart. Okay, so this discussion is implemented respectively in these two charts. So we have 3 steps to find the revised central lines and control limits. So first, you need to update your X double bar and your R bar. In your enumerator, you need to deduct the average of the subgroup that has been discarded. And you also need to discard the number of these subgroups, right? So you have smaller number of subgroups now. And similarly for the updated R bar, the R bar new, in the enumerator you need to deduct the subgroup ranges that has been discarded, and then deduct the number of discarded subgroups here. And second, you need to find some standard values. So the standard values are the X bar 0, R 0, and sigma 0. So the X bar 0 is the same as the X double bar new, and the R 0 is the same as the R bar new, and then the sigma 0 is defined as R bar divided by D2, where D2 is a factor, a value from table B. So you need to look up for this value associated with your subgroup size. And after we got these 3 standard values, you can compute the control limits using the following formula. So the upper control limit and the lower control limit for X bar equals to the X bar 0 plus and minus the A times the sigma 0. So now you already have these standard values, X bar 0 and sigma 0, and this A value should be read from the table B. And for the upper control limit and lower control limit for the R chart, you need to look up for the D2 and D1 value in table B, and then find the product of D2 and sigma 0 defines the revised upper control limits for the range. And then the D1, the production of D1 and sigma 0 defines the lower control limit for the range. So now if you expand this formula for the UCL Xbar, this one, this sigma 0 is defined as R0 divided by D2. And if you can verify that from your table 2. So in table 2, the A2 value is the same as the A value divided by the D2 value. Okay, so you can replace this A divided by D2 with A2. And then therefore you can see that the UCL, the upper control limit for Xbar in this revised central line is just the same as the updated X double bar plus the A2 times the updated R bar. And this is actually same as the formula that is used in the trial control limit. So essentially these are two equivalent definitions, equivalent formulas. If you have this updated X double bar and updated R bar, you can actually use this formula to compute the revised upper control limit. This will give you the same value as conducting these 3 steps and using this formula. So here is an example. In our Xbar chart, we discard 2 data points, right? 2 subgroups, the subgroup 4 and subgroup 20. And therefore, you need to deduct the averages for subgroup 4 and then deduct the average for subgroup 20. And of course, the total number of subgroups now you have is 23 instead of 25. And so the updated X double bar is 6.40 millimeter. And for the R chart, we only discard 1 point, the subgroup 18, right? So you need to deduct the range for the subgroup 18 from the enumerator, and then deduct 1 from the total number of subgroups, because now you have only 24 subgroups. And the updated R bar value is 0.079 millimeter. And now you need to establish these standard values. So from table B in the appendix, and then for a subgroup size of 4, right? You have 4 samples in each subgroup. For this subgroup size of 4, you can check that lookup for this value D2 equals to 2.059. And therefore, you can set up this X bar just equals to the updated X double bar. And then this R0 equals to the updated R bar. And this sigma 0 is computed as R0 divided by D2. Okay, so R0 is something that you already computed, and D2 is the value that you look up in table B. And therefore, we got these 3 standard values. And then in step 3, you need to use these formulas to compute the control limits. So what you need to look up in the table is the value of A, which is used in establishing the control limits for X bar, and also the values of D2 and D1 in establishing the control limits for the range, for the R chart. Okay. So here is a comparison of the trial control limits and the revised control limits. For example, for this X bar, you have this upper control limits and lower control limits are shifted down a little bit, right, from the trial control limits. And this updated X bar, the X bar 0, is also a little bit shifted down from the X double bar. So these trial control limits are designed for your current subgroups, and then these revised control limits are defined for your future use. When you have more subgroups coming up, you have more inspections, then you are going to have to use these control limits. Assignment 5 is associated with this lecture and will be due next Thursday. There are some hints about this assignment on our slides, on the last slides of today's lecture. So please read that hints for your homework. Good luck and bye-bye.